Again, welcome to Statistics. This is DSRT 734 class. In these lectures, we're going to discuss about linear regression. So again, the previous lectures, we went through correlation. And the concept of correlation is to find a relationship between two variables. Here, we're going to continue with linear regression. Also, linear regression, our main goal is to find a relationship between two variables, but also to be able to make a prediction. So we're going to find something we call the best fit line or the regression line. And the regression line will be a model that we can use to predict a future dependent variable based on independent variable. We have a simple linear regression, which means we have only one independent variable that will determine the dependent variable. So example, X will determine Y. And in the future, with any S value, we can predict what Y value will be. So the objective is to find the equation of a regression line, which is the model of the regression line. Also, some textbooks use the term best fit line. Also, we're going to predict Y values using the regression equation. So these two lectures, first, we are going to learn how to find the regression equation. Then we are going to use that regression equation to predict the dependent variable. So how do we find the regression equation? When we have the data set, we will use the data set to come up with the regression equation. And here we are going to deal with a straight line. So this is a linear regression. So example, a linear regression will be a best fit line that will reduce the residual. We use the term residual. Residual means the error between the actual value and the predicted value. So for example, if I have a data set here, the actual data set are the points we have. And I was able to come up with a regression line, which is my best fit line. Now we can see that on the line, we are going to have a points on it. So let's say we are here at my mouse pointer. This is the actual value. Straight down to the line, we also have the predicted Y value. So the difference between the predicted Y value right straight to the actual value, the difference is called the error. So our main goal, actually that's why we use the term best fit line. The best fit line means the line that will have the minimal error or the minimal residual. So for example, I can have, by looking here, we have a one straight line. I can have as many straight lines as I want in this equation. But again, it may not be the best fit line. This is the one best fit line, which means it has the minimal error or the minimal residual. So here we say after verify that a linear correlation between two variables is significant. And how do we verify it? That was our previous lectures. So if I have two variables X and Y, and I want to see if there's a linear correlation between them, all I need to do is to find the correlation coefficient or use the scatter plot to plot the point and see if there will be any pattern, a straight line pattern. So here we say after we verify that the linear correlation between two variables is significant, next we are going to determine the equation of the line that best models the data. The term best is again any line that have the minimal error, which we also call the best fit line. And here we are calling it the regression line. And now, if we were able to get the regression line, we can use it to predict the value of Y for a given value of X. So let's say, for example, we can see our last point here. Let's say it's in 2020. So to my right, maybe we have 2030. And now if I know 2030, based on this line, I can tell what will be the value of it in 2030, the value of Y in 2030. So again, we start with the residual. As we said earlier, residual is the error. So residual is the difference between the observed Y value and the predicted Y value for a given Y value on the line. So again, residual is an error. When the residual equal to 0, it means the actual value of y is the same as the predicted value of y. So we can see the straight line again. Our actual value is the blue dots. And then the predicted y value is on the line, or the points on the line. So if the blue dot is on the line also, then that very moment, the predicted value is the same as the actual value. So the residual will be 0. So when we start with the first point, we have the point 1. With the predicted, again, it have to be a straight vertical line to the line. And we can see that we have different y value, predicted y value from the actual y value. So we have D1. D1 will be the difference of the actual value and the predicted value. D2, which is the distance on the point 2 and the predicted value point 2. The difference of it will be, again, D2. Then we have D3, D4, D5, D6. In this case, all the predicted values are not the same as the actual values. So we have, again, a residual for each actual value and the predicted value. And this is the formula here. So the I is the observed y value. Observed y value is the actual y value, in this case, the blue points, minus the predicted y value. The predicted y value will be the y values on the best fit line or the regression line. So we say the regression line, again, a line of a best fit, or sometimes we say the best fit line, is the line for which the sum of the squares of the residual is minimum. So our goal is to reduce the error as much as possible. Here we are using the term the sum of the squares of the residual, because when we go back to the equation, you can see that some of the residual values will be negative and some will be positive. So sometimes when we add all together, the positive values will cancel the negative value. Then sometimes we may end up getting 0, but actually 0 means there's no any error, but here we have an errors. It's only that some errors are positive values, some errors are negative values, so they will cancel each other. So for us to avoid that, we always square the residual. So when I find the residual D1, I will square it. D2, I will square it, D3, D4, so that all the values will be positive values. Then we add all together. So a best fit line, or a good regression line, is a line that have the minimal sum residual square. Because when we find the residual, we square each value, then we sum all together. And that's what we mean here. The line for which the sum of the squares of the residual is minimum. So each residual, we square it, then we sum all of them. And the best fit line will be the line with the minimal sum of the squares. Now, the equation of a regression line, remember this is a linear regression or linear association. So which means this takes us back to college algebra. In college algebra, the equation of a straight line is y equal to ms plus b. Y is our dependent variable, m is our slope. The slope will determine the steepness of the line. Then b will be our y-intercept. So it's the same concept of college algebra straight line equation. It's almost the same as 0. Again, we have different type of regression line. We can have nonlinear and linear, log, exponential, etc. relationships. But here we are talking about straight line. So this will be our, here y caret means the predicted y value is equal to ms plus b. Now we're going to learn how to find the m and how to find the b. In college algebra, it was easy. Why? Because all the points are on the line. So to find the slope, you take any 2 points on the line. Let's say point 1, point 2. Each point have an x1 and y1. Point 2 is s2 and y2. So the slope will be y2 minus y1 over s2 minus s1. That's for college algebra because all the points are on the line. In statistics here, the points are not on the line. So we have a special formula we have to use to find the slope and also the y-intercept, which is the b. So again, we say the m is the slope and the b is y-intercept. And our y caret is the predicted y value for a given s value. So s is our independent variable. Now, if we want to find the slope, this is the formula for the slope. Because we have the equation, we don't know the slope. So the slope will be the sample size, the product of sy sum minus the sum of x times the sum of y, divided by the sample size again, the sum square, the s square sum minus sum of x all square. So we talked about this in our previous lectures. S square sum means we square each s value, then we sum it. Sum s square means we sum all the s value before we square. So that's the formula again for the slope. After we get the slope, then the y-intercept, which is the b, will be the y. The y bar here means the average of y, not the y caret. So to find the y-intercept, it will be the y mean or average minus the slope times the average of x value. So we know that the average of y value will be, you add all the y value divided by n. N is the size of the sample. So that is the number of items. The same thing to find the average of the x, we add all the s and divide by n, because that is the sample size. So the formula will be the sum of y divided by n minus the slope, the sum of x divided by n. So always we need to find the slope first, then we can find the y-intercept. So let's try this example here. Now this is almost the same question we had in our previous lecture, the correlations. Here we have a company that have some advertising expenses, and then the company sells. When the advertising expenses is $2,400, the company sells is $225,000. When it's $1,600, it's $184,000. When it's $2,000, the sales is $220,000. So these are the data sets. So we are assuming that advertising expenses is the independent variable because it will determine the company sales. So we give it as X, and the company sales is Y dependent variable. Now our question here is that we need to find the equation of the regression line for these two relationships, for the advertisement expenditures and then the company sales data. So the first thing we need to do, we remember the slope formula. We have the product of SY and the sum of S all square, and then the sum X square, etc. So we make the same thing. We have S and our Y value, so we find the product of S and Y. Then we find the S squares, then we add all together. SY also, when we get it, we add all together because we have sum XY in our slope formula. Then we also have the S square, we square each S we had. Then we square each Y we had. And then we said the parenthesis sum X all square means you had all the S value, then we sum it. But S square sum means we square all the S, then we had. So here we are going to enter the formulas. The formula is again the sample size times the sum of product of XY minus the sum of X times the sum of Y divided by, again, the sample size multiplied by S squared sum minus sum of X squared. So let's plug in the values. We have the sample size is 8. The product of XY sum is 3289.8 from the previous table. And we find the sum of X was 15.8, sum of Y was 1634, divided by N again, sample size is 8. S squared sum is 32.44. Then sum S all square is 15.8 squared because sum X is 15.8 all square. So if we use our calculator, our final answer will be 50.72874. So we know the slope now. Next, we can find the y-intercept, which will be the y average minus the slope times s average. We already have the y and average and x average. Y average will be the sum of y divided by n. X average will be the sum of x divided by n. So we plug in the value 1634 by 8, multiplied by the slope. The sum of x is 15.8 divided by n, 8. And when we use the calculator to solve this problem, we get 104.0607. So now we know the value of the slope, we know the value of the y-intercept, m and b, so we can find the regression line now. So the regression line will be y caret equal to the slope. The slope is 50.729 times the independent variable x plus the y-intercept, which is 104.061. So that is the answer. Again, the question said we should find the regression line. So find the equation of the regression line for the advertising expenditures and company sales data. So we have x and y. We were able to come up with the sy. That's the product of sy each, then we sum it. S square each, then we sum it. Y square for each value, then we sum it. Then we plug in the values to find the slope. Then after we find the slope, we find the y-intercept, which is the y average minus the slope times s average. We also plug in the value and get the answer. So we know the regression line need only two things: the slope and the y-intercept. X is our independent variable, y caret to be our predicted y value, which is the dependent variable. So to sketch this, we can also use the scatter plot, and we come up with this. Now, if you are using Excel, that is very beautiful, or any software applications for statistics. When you come up with a scatter plot, we are going to just select the point, the option for this, the best. Normally, we right click. If I'm using Excel, I'll right click any of the points, then I'll select trend line. Excel called the best fit line or regression line as a trend line. Then I'll see the line. Then I will go and look for an option to display the equation, and this will be the equation. And after we finish the lecture again, I'm going to use the Excel to solve a problem here, to find both the correlation and the regression line. So that's what you say, using technology to find the regression equation. We have to plug all the points in our application if it's Excel. Then we select the points. Then if it's Excel, we can find both, again, the correlation and also the regression line. Again, the steps are not here. I'm going to do it in a few minutes. Now, predicting y value using the regression equation. So now we know the regression equation now, which is y caret equal to 50.729x plus 104.061. So any value of x, I can find the y prediction. So for example, here they say we should predict for 1.5 thousand, which is 1,500, 1,800, 2,500. So I'll start with the first one. I'll plug in 1,500 for x, which is 1.5. The cells will be 180,155. 1.8, just plug in for the x. Our new y value will be 195.373. We can see that the slope is positive. So again, our relationship will be an increasing relationship. So when it's 2.5, it will increase more, 230,884. So that's the summary of these lectures. Again, in these lectures, we find the equation of a regression line, and also we're able to predict y value using the regression equation. So now I'm going to start with my Excel here. So I have an Excel program here. and I'm going to start it. So here, I'm just going to pick any points. I don't want to take a long time here. So for example, I'm making any values here. You can see the value I'm making 6, 7, then 8. Then I'm going to select it. So I'll get 6, 7, 8, 9, 10 as some value. So let's assume this is our X value. Then we have a Y value. And the Y value, again, we can plug any value. I'll start with 10. Then maybe 20. And then let's see if we get some nice values here. Yeah. I'll change some of the values so that it doesn't look too perfect. We get some outline. So you have 2 coming somewhere. Let's say this is 12. We have 12 twice. Again, it doesn't matter. The value can be any value. So I'm just selecting any value here. So let's assume this is the question we have in Excel. I'm using Excel to solve this problem. The question said we should find the correlation coefficient of this data set. Let's say X is our company advertising expenses and Y is the company sales, the revenue. We want to find the relationship between the two. So the first thing I'm going to do is to select the value, and then I'm going to the FX to set in the function. I'm doing the correlation first. So let's say I'm going to put the correlation value answer here. So let's put it here. Then I'll go back to FX again. And the correlation function name is CORREL. That's the correlation function name. Now, if you are not sure of the name, select any function, look down. Here they say return the correlation coefficient between 2 data sets. And that's what we are looking for. The correlation coefficient between X and Y, 2 data sets. Okay, so that's the function we are going to use. So I'll click OK. Now I have to select the first set of values, which will be the X values. I can enter the values using my keyboard, but the quickest way is just to select the value and drag it. So this is the values I'm going to use. Then I'll go to the second. Then I'll go to the Y. Then I'll select the values also. Now, one thing is that the number of S values have to be the same as the number of Y values, because we have a set of SY. So here everything is correct. The number of X is the same as number of Y. And we select our correlation. So I'll click OK. So we can see the answer here. The answer here is 0.8 something, which is very good value. Let me make it larger, which is a very good positive value, because we can see that the values are increasing. The reason why we don't get 1, because let's say from 100 to 110, 110 to 134, the difference are not the same. And that's why I change it. Now, if I make the difference at 6, 7, 8, 9, 10, and 10, 20, 30, 40, the differences between each Y and S values are the same. We'll see that we get perfect 1. I don't want that, so I change some of the values. So this is how we find the correlation coefficient using Excel. Enter your values in the cells, then select your function. The function name is correlation, CORREL. Then when you select the function, then you select the data set for your X and Y. Excel will call it array 1, array 2. So you enter those 2. Now, when you are looking for correlation, we said it in the theory. It doesn't matter, S can be the dependent variable or S can be the independent. You can reverse it, you get the same answer. Now, we want to do a regression equation. So what I will do next is I'm going to select the same value, because I want the equation to come from this value. So I don't need the R. R is the correlation coefficient. I'm using the data set. Then I will go to Insert. Then I will click on Chart. I'm looking for the scatter plot. So let's make sure this is scatter plot. I can see Insert Scatter. So this is right. So you guys, the type of scatter doesn't matter. It can be the 3D or in the graph one. I'm just going to select the simple one, the first one. So this is my scatter plot. I can see the increasing relationship. The reason why we didn't get 1 because of these 3 points. If it's the same increasing, then it will be on the same line. You can see the rest almost in the same line. Now, the next thing I'm going to do, I'm going to right-click any of the points, select any of the points, right-click on it. Then you will see the hard trend line. This is hard trend line, and that will be my best fit line. So Excel generated this line that this is the best fit line. Now, I'll go to my right side, and I'll look for equation, display equation on chart. So I'm going to display the equation on chart. And when I click on it, you see the equation is here. So this is what we are looking for. This is the equation of the regression. Let me maximize it or increase the size and move it down somewhere. Let's move it out. Okay, seems like we can't move it out, so let's leave it where it is. Okay, now we can see it better now. Let me take it back, undo it once. Yeah, so now we can see the line. Again, this is our best fit line. How do we get it? Right click on any of the dots, then click hard trend line. Then on the right side, you will see display the equation. So here our slope of this data set will be 7.6452. Our y-intercept is 17.548. So now any value of x, I can be able to predict y. So again, this is how we use the Excel to find both the correlation coefficient and also the regression line. So again, that will be the conclusion of our lectures. So in these lectures, again, we learn how to find, in the previous lectures, we learned how to find the correlation coefficient, how to plot the scatter plot. In this lecture, we learn how to find the regression line or the best fit line, and also how to use the line to predict any y value or any dependent variable based on the independent variable. And here we are assuming the independent variable is only one variable. In the next lectures, we're going to discuss about multiple regression, which means we can have more than one independent variable. In this lecture, we have only one independent variable to predict dependent variable. So again, wish everybody the best and thank you for your time.